Hello all, let's start section 4.3. 4.3 is addition rule. Addition here doesn't mean that we are just adding few numbers. There is a rule for probabilities, for adding those probabilities that I will go first explain it in few examples. Then I'll give you a formula or a rule for addition. Then we practice that rule with few more examples. Let me start with before addition rule. Let me introduce to you what is a compound event, right? Compound event. I'll put a simple definition. An event which joins two or more simple events, which joins two or more simple events, we call it compound event. For example, probability of rolling a 1 or a 5. Here you see you have two simple events. You roll a dice once, the probability of having 1, which is of course 1/6, correct? And I call this one a simple event. And you roll a dice and you get a 5, correct? Which is again 1/6. Actually, compound events joins these two simple events with each other. The word or that you see here, or, means here for us addition. It joins two simple events or even more, correct? Let's talk about or. Or means one or the other, or both. That's the meaning of or. One or the other, or both of them. This is what we call or, correct? That's the meaning of or in our notation, and soon I will give you the notation, correct? I will do an example later, but let me write down what does it mean in general. We have the probability of A or B. What does it mean based on this translation that I have here? Probability of A or B. It means probability of A, event A, occurring or B occurring or both A and B occurring. This is the meaning of this notation. Probability of A or B means A is occurring or B is occurring or both occurring, A and B. correct? But the rule is, I will write down here, in a single trial, correct? It should happen in a single trial. Of course, the example of dice will not work here because in a single trial, you cannot have 1 and 5 together, correct? That example will not work here. That's why I want to do another example for you. Another example that right now it comes in my mind is if I write the probability of someone who is blonde or female. For example, in your class, how many students, they are blonde and also they are female? You see, two events at the same time can occur. Someone, a female, one of my students, can be blonde, which is A. I can say this is event A, correct? Or someone can be blonde and be a boy, correct? Not a girl, a man, not a female, male. Or it can be just a female student of me, but not blonde, which is your probability of B, even B. Or someone can be female and blonde, both of them. You see, event A or event B or both, correct? These events another example that I want to do here for you is a court example. Some of you may already know what a court is, and you may already went to court, at least to be there as a jury, or maybe you went to just see the process there. I will do this example here. The example of a court. I'll just put numbers first in this table. For example, here 11, here 72, maybe here 9, maybe here 85. Correct? When someone goes to the court, the judge has two decisions to announce. Correct? Someone, he can announce guilty or not guilty. Correct? Two options. If not guilty, happy, go home. If it's guilty, of course, there are other processes. Correct? Guilty, not guilty, two decisions. Now, in this table, for example, in one of the courts, usually it happens, we have these incidents because we are human beings, we have error always. In this column, I will put didn't do it or did not do it. In this column, I'll just put did it. Correct? This 11 people announced by judge guilty. But do they actually commit a crime or did it? No. But because the decision of the judge was guilty, they are guilty. 72 people announced by judge guilty. Correct? Do they really commit a crime? Yes, because they are under the column of did it. Correct? Judge announced 85 people not guilty. Correct? And it's true, they are not guilty because they didn't do, because they are under the column of did not do it. They didn't do it. And also another 9 people here in the last cell, 9 people that they were announced by judge not guilty, but actually they committed a crime. There was lack of evidence or whatever the reason was, they are not guilty. Correct? And the first, which I have 11, we call this false positive. This is false positive. 72 is true positive. Why we call it positive? Because it's based on the decision of the judge. If guilty, we call it positive, not guilty, negative. Correct? 85, we call it true negative. And 9, we call it false negative. Why I'm doing this example? I want to answer this question. How many people are guilty or did it? We want to answer this. How many people are guilty or did it? Correct? To find the people who are guilty, I have to look for the first row, this row, like this. This is the number of people that the judge announced them guilty. It means 11 plus what? 72. To find the number of people that they did it, I have to look to this column. This column is 72 plus 9. And if I total this, 72 plus 72 gives you 144. 144 and 11 gives you 155. And 9, 164. Correct? But if you focus here, there is a mistake. This number is larger than what we have in reality. Why it's larger? I will show it here for you with different color. You see this 72 here? I count 72 double. I did a double count. Correct? We have to remove one of these 72s because 72 is also in guilty and you are event A, if I name it event A, and also in did it if I call it event B. Correct? In addition rule, we always avoid double count. Correct? We always avoid double count. Then what is the true number here? 11 plus 72 plus what? 9. 9 plus 11 gives you 20. 20 plus 72 gives you 92 people. Correct? This is the actual count that we should do. Remember, you have to avoid double count. Correct? Before we discuss which kind of events, we call them mutually exclusive. Correct? We discussed this. We have, if you see here in this example is not mutually exclusive. Correct? It's not mutually exclusive means they cannot happen at the same time in one trial. But here you see it's happening at the same trial. This 72 tells us that it's not mutually exclusive. Correct? Now, if I ask you here in this example, what is the probability of someone find the people that they are guilty or did it? If I want to find this probability, it means the people who were guilty, we found it's 92. Divide by what? Divide by this total number of people that they went to court. 11 plus 72 plus 85 plus 9, which gives you 177. If you add this four number, it gives you 177. Because we are talking about probability, right? Then 92 over 177 people, they were guilty. Correct? It means how much? If you simplify it in decimal, it gives you 0.520. Correct? It means 52%. Correct? Now, after this example, focus on this counting here that I avoid double count. Now, let me write the addition rule for you after this example. Addition rule. P of A or B equals P of A plus P of B minus double count, which this one will be the notation P of A and B. This is your double count. The probability of event A and B at the same time happening. That's your double count, correct? This word is tricky, and. In this lecture, and has one meaning, but in my next lecture, when I explain to you the multiplication rule, and has another meaning. Then let me give you a little bit of note here for this and here means A and B occurring at the same time and a single trial. In a single trial. Remember this, note this, and means the event A and B is occurring at the same time in one single try. Correct? Later, we will do examples for this, but let's have some more notes. I will introduce here the word disjoint. Disjoint or disjoint events. Disjoint events are events that they are mutually exclusive. And another word, mutually exclusive, the name of, instead of using two words, mutually exclusive, you can call it disjoint. They have the same meaning. Mutually exclusive, if you remember, I told you, the meaning of mutually exclusive is cannot, again I'm writing one more time, cannot happen at the same time. At the same time. That's the meaning of mutually exclusive, or this is the meaning of disjoint. Two or more events that they cannot happen at the same time, like rolling a dice. When you roll a dice, if you look for the having 1 and 5 in one trial, it's impossible, right? You cannot have 1 and 5 in one trial. Correct? Let me show you this concept in a Venn diagram. Correct? Something happened to my pen. Venn, I think it has double N. Venn diagram. What's going on? Venn diagram. Correct? Venn diagram is actually showing sets this way. Two circles, we put it nicely in a rectangular shape. Correct? If I name my first circle P of A, correct? And the second circle P of B, you see these two circles, these two sets, actually they are sets, right? For example, if I write down this one in set notation, your P of A actually is this set. And the example of the court, P of A was guilty, correct? Your P of A means guilty, which was 11 and 72, correct? Your P of A is 11 and what? 72. Your P of B is 72, and I think the other one was 9 or what? Let me check. 72 and 9. Correct? This is the idea of set here. 72 and what? 9. You see 72 is in your both sets. It means your 72 is actually here in this intersection. We call it intersection when we are dealing with probability. This overlap. This 72 is in both sets. That's the overlap. Correct? Then this Venn diagram actually in statistics shows for us none disjoint. Or you can call it simply joint. Correct? This part, the shaded part, is P of A and B. Correct? Now, I will draw another Venn diagram to show for you disjoint events. Let me draw another one. Again, I'll draw two circles, but this time like this. One circle, another circle. This is P of A. This is P of B. Do you see here, these two circles, they don't have overlap, or in mathematical language, they don't have intersection. Correct? That's why we call this disjoint. For example, probability of rolling 1, if I show this one as a set, is like this. Probability of rolling 5. P of A is 1. Let's name this one A. P of B is 5. There is no overlap between 1 and 5. Correct? Then this one will be a good example for disjoint, rolling a dice. Rolling a dice is a good example of disjoint probabilities. Now, a quick question that we have, or we can answer here. Let's find answer for this. What is the probability of A and B in a disjoint event? Look at here. Look at this disjoint diagram. What is the probability of A and B? Do I have overlap? No. Then I can say the probability of A and B in a disjoint event is always equal to what? 0. Because there is no overlap. Because the events are disjoint. Correct? There is no overlap. That's why it's always 0. Correct? And the formula that I just put for you a few minutes ago, which is your addition formula, P of A or B equals P of A plus P of B, probability of B, minus probability of A and B. Remember two things. This formula works very well if you are, for both of them, if your event is not or non-disjoint. You always have this. If your event is disjoint, then even you can use this. Probability of A or B equals probability of A plus probability of B minus, for this joint, you see, I told you this part becomes 0. It means you can only use this. I never want to give you two different formulas. Oh, use this one for this joint, use this one for non-disjoint. Only focus on this. It works for both of them. The only difference is when you read the problem or the example, you take your decision. You think that, is this example is a disjoint or non-disjoint? If it's disjoint, immediately the last part of the formula, which is P probability of A and B, that becomes 0. If it's non-disjoint, then you have to always subtract your overlap, like the example of the code. Let's do a few more examples with this formula. Find the probability of randomly selecting a heart or spade in a deck of cards. Immediately write down your formula. Translate your formula. Probability of a heart or what? A spade. I'll try to draw a nice spade here, but I cannot draw. I'm not good in drawing. Correct? Probability of a heart or what? A spade. Then, how to translate this? Probability of heart plus probability of a spade. Now, think about minus probability of heart and what? A spade. You see, I'm using formula number 1. I don't want to use the second one. Now, I'm thinking, find the probability of randomly selecting a heart or a spade. Is this example is a disjoint or non-disjoint? If you focus a little bit, you will find that this example is actually disjoint. Because between heart or a spade, there is no overlap. One of them is even black, one of them is even red. Two different shapes, correct? There are two separate events. There is nothing, there is no overlap. They are disjoint, correct? Then, what is the probability of having a heart? How many hearts we have in a deck of cards? 13. How many total? 52 cards. Plus probability of having a spade. You have 13 spade and 52 cards. Minus, because this is disjoint, this part becomes 0. Correct? Then it's equal 26 over 52. And if you divide by 26 or by 2, it gives you 1/2, which means 0.5. Correct? And 0.5 means 50%. This probability is 50%. Correct? Let me give you another example. Find the probability of blonde or a female, a blonde or a female, if I give you this blonde, for example, it's a class of students, right? Blonde is the probability is 0.18. Female in that class is 0.60, and blonde female is 0.12. Now, looking to the probability, you can write probability of what? You just copy this inside the parentheses. Blonde or female equals probability of, I'll use B for blonde to make it smaller, plus probability of female, I'll use F for it, minus probability of blonde and female. Now it's the time to think, is this a disjoint event or non-disjoint? This example is non-disjoint, right? Look at here. It's non-disjoint. Why? Because someone can be both, right? You can be a female and also you can be a blonde, right? It's both. That's why it's disjoint. Then plug in just the number. What is the probability of blonde? 0.18. Plus, what is the probability of female? 0.60 minus, because it's non-disjoint, it's not 0. What is the probability of blonde female? 0.12. And if you simplify, you will end up with 0.66 or 66%. Correct? One more example. Let me give you enough examples here for this lecture. Find the probability a diamond or king in a deck of cards. Correct? Means this. Find this probability. Probability of a diamond or a king. First, your formula. P of diamond, correct? Plus P of king minus P of diamond and king. Correct? Now think, is this a joint or disjoint event? Or I can say, is this disjoint or non-disjoint? Of course, you see, a king can be also diamond, right? There is an overlap because you have 4 kings and one of them is diamond, definitely. There is an overlap here. Then this one is non-disjoint, correct? Now, what is the probability of having A diamond, 13 over 52. Plus, how many king you have in a deck of cards? 4 over 52. Minus what? Where is the overlap? Diamond king, a king of diamond, which is 1, right, in your deck of cards. Over what? Over 52. And if you simplify this, 13 plus 4, 17. 17 minus 1 gives you 16. Over what? 52. Which approximately, I think, it's 0.310. Correct? Now, one more short topic here that we will discuss. Then we are done with section 4.3. Let's discuss complementary events. We already know the formula for complementary events, correct? But here for addition rule, P of A or A bar or the complement of A. If I write the addition rule, it's equal to P of A plus P of A bar or the complement of A minus P of A and its complement, A bar. Correct? You see, like, because the complement of an event and its complement is disjoint, right? Because if you look for an example of rolling a dice, if your event is 2, the complement of 2 is 1, 3, 4, 5, and 6. You see, 2 is not there. Or think about yourself. At one time, you can be in one place. You are in my class. You cannot be in my class and also in a physics class or biology class, correct? This P of A and the complement, it's a disjoint event, right? Then, if it's a disjoint, it means this part becomes 0. Then you can say probability of A or complement of A equals P of A plus P of A bar or the complement of A, and you already know it's equal always to what? To 1. Correct? A quick example here. We are looking for the P of girl. P of girl is given to you. Probability of having a girl is 0.512. For example, a couple wants to have a girl, correct? The percentage of having a girl is higher than the percentage of having a baby boy, correct? It's 5.5, it means 51%, correct? 51% for girls. They are asking you here to find the complement of, or find the probability of boy, not the complement. Find the probability of having a boy. Easily, here you can use the complementary formula, correct? P of a boy, probability of having a boy, is actually, can I write this way? It's equal to the probability of having Girl and a bar in the top. The complementary of a girl. Correct? And this one will be 1 minus P of girl, right? We did this lecture before. It means 1 minus, what is P of girl? 0.512, which gives you 0.88 something. Yeah, 0.488. Correct? We, I did a quick example because we covered before the complementary events. Actually, here, based on the addition formula or addition rule, they explain it one more time for you. Because when I explained the complementary rule in previous lecture for you, I didn't mention if it's disjoint or joint, correct? But here, because you know now it's a disjoint even, you know it better. I will stop the lecture here and see you all in section 4.4.